In this video, I would like to show you how you can turn your Linux machine into a guitar amplifier and effects processor. The machine I'm recording this video on is running on a Fedora Linux operating system, but most of the instructions I give in this video can be applied to different Linux distributions as well. Now, the first thing I want to show you is how you can actually set up the Jack audio server and set up your audio hardware, your audio interface, etc., so that it works for real-time processing in under Linux. Now, if you haven't done any real-time audio work on your Linux system yet, you might need to install the Jack audio server on your system first, because it might not yet be installed. The way you do this is you open up a terminal, and then it depends a bit on your distribution. If you run a Debian-based distribution like, either Debian itself or Ubuntu or Linux Mint, you will have to use a command like sudo apt-get install, and then you type the name of the package you want to install. In our case, we want to install qjackctl, which is a Qt user interface for the Jack audio server. And in case the Jack audio server is not yet installed on your system, qjackctl will automatically pull Jack and all the other stuff as a dependency. Now, if you're not on a Debian-based distribution, but instead on a Red Hat-based distribution, instead of using apt-get, you use DNF, which is the package manager for Red Hat. DNF is short for identify. And and so you say sudo dnf install qjackctl, and then you hit enter, and then you have to type your user password, and then it will refresh some package information from the internet, etc. And in the end, in my case, it will tell that qjackctl is already installed because I already have it on my system. But in your case, it might be required that you install this software first. And like I said, it will automatically pull the Jack audio server and everything else you need for real-time audio on Linux as a dependency. Now, okay, in my case, as you can see, we got the message that the package is already installed on my system, so the package manager has nothing to do. But in your case, you might want to get you might get a list of packages, including qjackctl itself, but also dependencies, and the package manager might ask you if you want to install these packages, and in this case, you will have to say yes, install these packages. Now, I already got qjackctl installed on my system, but if you didn't have qjackctl installed on your system yet, then after you did this package installation, you will have the package installed. So we can now proceed. So we open up the system menu and we start qjackctl. And the first thing we have to do is set up the audio hardware. And to do this, we click on the setup button. And now there's the default settings look something like this, but we have to change a bit of these settings in order to get good operation for or good performance from jack. Now, the first thing you might want to ensure is that the driver that is selected is ALSA, which is the default Linux low-level audio API. Then you want to ensure that real-time mode is enabled. Next, you want to select the audio hardware that you want to use for real-time processing. And in my case, I have two audio interfaces. The first thing is PCH, is the onboard audio, and you do not want to use the onboard audio for real-time processing because, well, for two reasons. First, onboard audio normally does not have good latency properties, so you cannot actually achieve good real-time performance with an onboard audio chip. The second reason is that the onboard audio normally does not have the proper inputs. It does not have preamplifiers on the inputs, which are required to connect microphones, but also guitar pickups to your computer. So you will want to use an external, probably USB, but nowadays perhaps also Thunderbolt audio interface. In my case, this is a Behringer UMC 204. It's not the best interface in the world, and it's not. It's also not the most recent version, but for us now it doesn't matter. So we select the interface. Next, we have to set the sample rate at which the interface operates, and the UMC 204 has a native sample rate of 96 kilohertz. So from the sample rate dropdown, we select 96,000. Your interface probably will be able to operate at different sample rates. It will be able to operate at lower sample rates, and it might also be able to operate at a higher sample rate than its native sample rate, because it might internally just upconvert or interpolate the audio. But we do not get extra information from this interpolation, and it just stresses our CPU more because it has to do more processing. So from the sample rate dropdown, you normally want to select the native sample rate of your interface, and in our case this is 96,000. Next, we have the frames per period setting. And the frames per period setting together with the sample rate determines the latency latency we can get from our audio server and in consequence also from our audio applications. Now, with the effects processor that we will use later, we have an option to control the latency or the frames per period setting of the Jack audio server while the audio server is running. We can control the latency from within the effects processing application. So we don't have to tweak this setting. We will, can just set it as high as possible, which will give us the most reliable operation, but also very, very high latency. So we just set this to 4096 frames per period, which is the maximum which we can select in qjackctl. And yeah, later on we will be able to reduce the latency when our effects processing application is running. Now, in the Advanced tab, we normally don't have to do anything. If we didn't select the interface here in the parameters setting, we might also select the input and output interface separately in the Advanced tab, but in our case this is not necessary because we use the same device for input and output, so we can just set it here on the normal parameters tab. The only thing you might want to do on the Advanced tab is set the port maximum to the minimum number possible, which might save you a bit of processing power. I'm not exactly sure, but yeah, that's basically it. Then we can close the connection window, and then when we hit the start button, Jack will take over the audio interface. And if we do this, if we restart the Jack audio server, then the normal ALSA or pulse audio, which is responsible for your system audio, will no longer be able to access the audio hardware we selected here. So in our case, in my case, ALSA will lose access to the audio interface to which my microphone is connected. So the recording of my voice that you're currently hearing alongside this video will stop. So therefore, I will just pause this video here, and then I will start the Jack audio server and then continue the recording with an application that can cooperate with Jack and not with ALSA for recording the voiceover that is added to this video. So because of this, I will now make a cut in the video, and I will come back later when I have the Jack audio server running. Okay, we now have the Jack audio server running, as you can see. And if we open up the connections window, you can see that there are two input ports on my audio interface, named Capture 1 and Capture 2, and 4 output ports. And you can also see that there's an additional Jack client over here, which is called Simple Screen Recorder. And this is the application that I use to record the screen. Use the screen capture that you see in this video. And I have connected my microphone to the second port, to capture port 2 of my audio interface, and I route the audio from this input to both inputs, so both stereo sides of the video capture software. You can ignore these two connections there just so that you can still hear me even while the Jack audio server is running. Remember that when you start Jack, it takes the audio interface exclusively. So ALSA can no longer access the audio interface when Jack accesses it. Therefore, I have to use Jack to record the voiceover for this video as well, and therefore you have these two connections. On your system, when you're not doing any video recording, etc., this Jack client will just not be there. It just won't exist. You will only have system on the left and on the right panel, and then of course these connections are also not in place. So just ignore these two connections. They won't be there for you. They're just for the voiceover in the video. So now that we have Jack running, we want to install some software that we can use to process the signal from an electric guitar. And the software we will use for this is called go-dsp-guitar, and you can download it from github.com/andrepxx/go-dsp-guitar. And on this site you will see a link that says there are a number of releases. In my case there are 2 releases. If you watch this video at a later point in time, there might be more releases of the software. So just click on the releases link, and you will see one of them is tagged as the latest release. So currently this is version 1.1.0. This is the latest release. And under this release, you can see it was released in the beginning of January 2019. And under this release, you can download the source code, but you can also download a binary package, which is this first file, and this is what we will do. So just click on the link and select Save File this will download the file into your downloads folder. And well, let's just quickly do this again. So we click on the download link and say save file. Okay. Right. Okay. Now it downloaded the file to our downloads folder. And after this happened, okay, we can close the web browser. We will open up a terminal again. We navigate to our downloads folder, and then we extract. So we can see that we got the tarball inside our downloads folder, and we can now extract it. And to extract the tarball, we use the command tar -x v zf. The X stands for extract, the V for verbose, the Z for gzip compression, and F tells tar that we want to operate on a file. And then we just type the name of the file. We can use autocompletion for this, and then we extracted the tarball, and it created a subdirectory for us called go-dsp-guitar, in which we can change. And inside this directory, we can see we get several executable files for different architectures, for Linux, for Windows, and also for different processes. And the executable we need to use with our system is this one, which is for Linux and AMD 64 processes. So we will just type /dsp linux AMD 64 and then hit enter. And then it will, when everything goes fine, it will say web interface ready and then this address. Now, if, for example, you don't have the Jack audio server running, you will get an error message, and it will return to your Linux shell. So make sure that you have the Jack audio server running, and then you should get this message. Now we can go to the connections window again, and we can see that we have. You will see that we have an additional client called go-dsp-guitar, and this client appears both on the input and the output side because it can take signals from your audio hardware or from another application, process them, and then generate output. And this can also be routed back to your audio hardware or to other applications. Now, in our case, we want to process our guitar signal, and our guitar is connected to capture 1. So we create a connection from capture 1 to input 0 of go-dsp-guitar. The inputs on your audio hardware are numbered with an index that is 1 based, so it's input 1 and 2, while the inputs on go-dsp-guitar are numbered with an index that is 0 based, so they are called input 0 and input 1. But it basically doesn't matter. You could connect capture 0 to input 0, capture 1 to input 0 and capture 2 to input 1, and then you could process the signal from both inputs, and you could route the outputs to your to the physical outputs of your audio hardware. Now, what I will do now is I will connect both inputs. So the first connection from capture 1 to input 0 is necessary for our guitar signal. Our guitar is plugged into the first input on our audio interface to arrive at go-dsp-guitar. So we have to make this connection. And now we can also route the second input, to which currently my microphone is connected, remember, to go-dsp-guitar. In this case, we could perform processing on the microphone signal. Say we could add some delay or echo or reverb or whatever, but we don't want to do this. I just want to keep my voice clean. However, go-dsp-guitar also creates a stereo mixdown of all processed instrument signals that you have. So we could cut these two direct connections from the capture port 2, to which our microphone is connected, to our screen recorder, and instead record these two master outputs from go-dsp-guitar, at which the mixdown arrives, and just record these, and then we basically get the processed guitar signal and the microphone signal. And we could also do processing to the microphone signal, which we don't want to do, but it will do all the mixing for us. So this is a possibility, and you can also route directly the processed signals. So everything that arrives on input 0 will get processed by go-dsp-guitar in the way you configure it, and the processed signal will arrive at output 0. Similarly, everything that arrives at input 1 of go-dsp-guitar will get processed in the way you configure it, which can be different from the other inputs. So you can do a separate completely separate processing for each input. And the process signal will arrive at output 1. And then basically it will also create a metronome track, which will just click for your synchronizations. It will just go like tuck, tuck, tuck. And this signal will arrive at this metronome output, and then it will take all these signals and process them again, put them in a stereo field, do some kind of simple room simulation applied to it, and then creates these two signals called master left and master right, and these basically contain all your instruments and everything. And you will normally use these two for monitoring. So I will connect the master left to my playback 3 and the master right to my playback 4 output, because the outputs 3 and 4 from my audio interface, they are currently configured to go to my monitoring speakers and also to the internal headphone amplifier of my audio interface. So I will get the entire mix down here. I could also route just the processed outputs to the other jacks on my interface. This way I could basically go from the other outputs, from output 1 and 2, say, into a mixing console and do the mix down there or whatever. There's a lot of possibilities, but I don't need this currently. I just want the left and right master channel to appear on my headphone amplifier, and this is the way I set it up. Yeah, and so currently I only have the guitar input connected, and then I could also connect the microphone input. And when I connect the microphone input, I could disconnect this direct connection to the capture process for your video, and then I could record the master signal. So let's just do this. I will cut these connections. So first I will establish the connection from the microphone to the second input of go-dsp-guitar. Then I will cut the direct connections, and I will connect the master the master output of go-dsp-guitar. So now you should still hear my voice in the video, but now the voice signal will pass through go-dsp-guitar, which will do basically no processing to it other than apply a simple room simulation, and then pass this on from the master outputs to your recorder. And the same output will also appear left and right channel on my audio interface and on my monitoring speakers. So, okay. But now let's open up a web browser, and then we just navigate to localhost:8080. we could navigate to this address or to https ://localhost 8443, which is the TLS port. But the other is simpler to type, so we will just type this. It will automatically forward us to the other address, and we will get a warning inside our web browser telling us that the connection is not secure. This is only because the certificate that we use for the TLS connection for the encryption is not signed by a trusted certificate authority, because this costs money, etc. pp. So there's no security risk in accepting this certificate, because we only make a connection to our local computer. Remember, we don't do anything with the internet. We just connect to the go-dsp-guitar service that is running locally on our machine. So there's no risk involved. We can press F11. We can put the web browser into full screen mode, and now we basically have the interface of go-dsp-guitar here. And you can see we have two signal chains here. The first signal chain consists of these three lines, and the second signal chain of these three lines. The way this works is basically we get our input signal from input 0, which is our guitar input on the audio interface. Then it will flow through a series of processing units, which we can put in between these two. So we can add a processing unit here, and after it passed through all processing units, it will get sent to output 0. Similarly, we have a second processing chain down here, which takes the signal from our input 1, which is to which our microphone is connected, passes it through a series of effect processing units, and outputs it to output 1. And then we have the spatializer down here and other units, and they create this master mixdown that we currently record to video. And yeah, we can just open some of these units here. The first unit is the latency unit, and there you can see you can configure the frames per period we talked about earlier. So this is currently set to 4096. We can increase this to a higher value, or we can also adjust it down. If we want to get an acceptable latency for playing guitar in real time, we would, at this sample rate of 96 kilohertz at which we are operating, we would have to set this setting to 512. This would give us a latency of approximately 5 milliseconds, which is very fast, and then we can just play guitar fine. Then we have an instrument tuner here. We can select from which channel it takes its signal, and we can use it to tune our guitar. I will demonstrate this later. Then we have this spatializer. This is what creates the stereo mixdown. Actually, we can see we can configure the position in azimuth and distance, so basically polar coordinates for both sound sources, and we can also adjust the level of both sound sources, and the level is currently at 100% for both. I can show you if I adjust this level slider down for level 1. Remember, level 1 or input 1 is where a microphone is connected to. Then you will hear that my voice will get quieter as I turn this down. And if I turn it up again, then my voice will get loud. If I turn it up again, then my voice will get louder again. So this is the way this works. This only acts on the master output. It does not act on the other, on the direct output from the chain. Remember, this is what gets fed out here. Yeah, we have this metronome, which we can use to create a click track. And then down here we have this signal levels view, which basically shows us the level of each signal going into each input and coming out of each output, and also the master output and the metronome. And currently there's no discrepancy between the input and output level, because we're doing no processing. We're just passing on the signal that arrives at our input. We're just passing on to the output, and what we get from this output, and also this output, but this, as you can see, the signal level on output 0 is very low. It's basically just the noise floor of our preamplifier. this gets summed up basically because we have no azimuth and no distance set, and arrives at the master output and gets recorded to your video. You can also see that the load on our DSP, on our signal processor, is currently very low because we're basically not doing any work. Yeah, so this is the way this works. Now, yeah, I will just do some basic demonstrations now. First thing I want to show you is the tuner, and I will set the channel to 0, which is where our guitar is connected to. And now the tuner will just jump around basically because it gets no signal to which it can log on. But I will just grab the guitar and plug some strings and make sure that that the guitar is in tune. So wait a second. So I just get the guitar, and I will now strum the strings sequentially and make sure that they're in tune. So this is the low E string. Next, the A string. And you can see the note value here changes accordingly to the A, and you get the frequency value and also the deviation in cents. So it is a bit off tune, but well, it's more accurate than you could get with any physical guitar tuner. So next, the D string, then the G string, then the H or B string, and then a high E. And you can see they're basically all in tune. E2, A2, D3, G3, H3, and E4. Okay. And well, basically we could just plug a string and then turn the tuner pegs, and you would see that the deviation moves up and down. So okay, so the tuner works fine, and we get the guitar in tune. And now I will just strum some strings, and so you can hear the dry signal from the guitar from the pickups. So I will just play some basic chords, like say an E minor, or an A minor, or a G, or a D, or C, or an F major 7. Okay, so this is what the dry guitar signal sounds like. Now let's just do some basic processing. We just want to simulate a simple guitar amplifier. And a guitar amplifier consists of two parts, of a preamplifier and of a power amplifier. And for the preamplifier, we got several units we can choose from. We can do fuzz, which does asymmetric clipping. We can do overdrive, which does symmetric soft clipping. We can do distortion, which does symmetric hard clipping. But for this video, I will just choose the overdrive effect, which is basic distortion. And then I will add a power amplifier directly after this. We could also put a tone stack. Okay, let's just put a tone stack in between, because this is how an actual amplifier works. So we got the preamplifier, the tone stack, and then we get a power amplifier. And these effects are currently all in bypass mode, so they're not doing anything. but we can still configure them. And yeah, let's just set the filter order to about well, let's say 4,000, which is reasonable. If you do, let's do 2,000, which is better for. No, let's do 4,000. If you get problems with latency or clicks or dropouts, you can reduce the filter order. So 2,000 will sound just fine. If you go higher, it will just get more, much more detailed and much more realistic. But it will be very hard to distinguish at this point. You can run up to 8 different power amplifiers or filters in parallel and control the level of each of them. And okay, so I will just use a British British power amplifier and the overdrive effect. And I will enable both of these, so go out of bypass mode. And then I will just pull the gain up. The gain is in decibels to 30 dB. And now I will play some chords again. So let's play an E minor. Okay, and let's play an A minor. And a G. D, C, F major 7, and so you can hear the guitar is affected by the preamplifier and the power amplifier. Okay. Now you can choose different amplifier models and of course you can choose other effects units, and you can arrange these effects any way you want. You can move them up or down in the signal chain, and of course the order will in which these effects apply will matter, yeah, as in the real world. And yeah. Now the last thing I want to show you is, in case you don't want to set up these want to manually set up these jack connections every time you run go-dsp-guitar. You can configure the connections one time in your configuration file, and go-dsp-guitar will automatically set them up for you. So you just open the configuration file with your text editor, and down here you will see a section inside the configuration file which is called connections, and it's by default when you download go-dsp-guitar it's empty, but you can put, well, you can basically put connections inside here, so descriptions for a connection that you want to establish inside your jack audio server. And the way this works is basically between these two square brackets you create new lines, and these new lines, in these new lines you just write an opening and a brace and a closing curly brace, and between these curly braces you write from in quotes, then a colon, and then you write again in quotes the source port from which your audio originates. And in our case we want to connect our capture input 1 to the input in 0 of go-dsp-guitar. Remember the inputs on go-dsp-guitar are zero-based index, and the inputs on your audio hardware have a 1-based index. So you write from system : capture _1, then you put a comma, and then on a new line 2 in quotes, colon, and again in quotes, go-dsp-guitar, colon, in _0. And this creates a connection from your system's capture port 1 to the input in 0 of go-dsp-guitar. And then you can just copy this section, put a comma behind the closing curly brace, and put another section below, and you can route capture input 2 to in 1 of go-dsp-guitar. So now you have both capture ports connected to go-dsp-guitar. Now you probably also want to route the master outputs from go-dsp-guitar back to your to the actual physical outputs on your audio hardware. And remember that I was using the outputs 3 and 4 from my on my audio interface for monitoring. So in my case, I would just copy this section again, put a comma, put it underneath, and route the audio from, this time from go-dsp-guitar colon master left, so left master output, to my system playback output 3. And similarly, again, comma, route from master right to playback 4. And well, basically would be all set. Now, if you only have an audio interface with 2 outputs, so just one stereo output, of course you would write playback 1 and playback 2 here, and you couldn't do basically couldn't do much else. But in my case it was 3 and 4, and now you can see I have 2 playback outputs which are unused, and by default go-dsp-guitar would use these for the processed signals. So remember at each processing chain had an end where it said 2 output 0 or 2 output 1, and we can access these as go-dsp-guitar out 1 and route them to playback output 1 and no, output 0. Again, we're 0 based, and then output 1 to playback output 2. And this way I could go from outputs 1 and 2 directly, say, to a mixing console and take the process signal from there, and then use the stereo mix down and route it to outputs 3 and 4 and connect my monitoring speakers and my headphone amplifier there. Now we got this all set up, and we can just hit Control S and save the configuration file. And now when we move back up to the connection window and run the DSP executable in our shell, we can see we just hit enter, and then we get all these connections set up automatically. So we, from capture port 1, we go to input 1, from capture port 2 we go to input, no, from capture port 1 we go to input 0, from capture port 2 we go to input 1, and then we go from output 0 to playback 1, from output 1 to playback 2, and from the left master to playback 3, and from the right master to playback 4. So you can see that go-dsp-guitar has automatically set up all jack connections for us, and we don't have to do this manually anymore. Of course, when we terminate go-dsp-guitar, it will just tear these connections down. But that's not what go-dsp-guitar does. It's just what jack does when the process dies. Of course, the connections will get removed because there's no endpoint that would actually take any audio data anymore. Yeah, so that's basically it. And I hope you enjoy the software and jam along and play good audio with your guitar. And yeah, have fun. Thanks a lot for watching this video.